My name is Jürgen Weiss. I'm an economist and a partner with the Brattle Group, an economic consulting firm based in the US and in Europe, and I'm going to chair this panel. I hope you'll all be able to stay awake through our lively discussion right after lunch. And I'm sorry you don't get to go to Stream A, which I think is about integrating renewables, because obviously the two topics are quite closely related. I heard several times this morning that storage is sort of the key missing link in making the future energy system work. And so we'll give you the answer of how that will play out, of course. As a matter of fact, I think it's a very, very complicated topic. And I have a lot of questions about it myself. I suspect in the best of cases you'll leave with more questions after we're done talking, but maybe with a slightly more sound basis for having discussions. So what I would like to do to give as much time as possible to the panelists who have very interesting and diverse perspectives on this, I will give a very, very quick intro now. I'm in the middle of it. And then I'll hand it over to each of the panelists to give a very, very brief, like 30-second to a minute background on themselves, and have them give initial comment to what I'm going to set out as a framework. And then very quickly we'll have an interactive discussion, hopefully, about these topics, which ideally will also involve you. So I'll kick this off by pointing out that as I thought about storage and this panel, there are a number of themes that create relatively complicated problems. And I'm just going to lay them out, 4 of them actually. The first one is that there are lots of different technologies that could address the same kinds of problems that storage is supposed to address. For example, there are multiple battery technologies out there that are competing with each other to some extent. There are various thermal storage options that exist. There is conventional gas turbines using natural gas in a world where greenhouse gas emissions are still permitted. And there is using some kind of biofuel and running it through a conventional gas turbine to provide some similar services to storage. There is transmission in some sense that could be used as a substitute for storage. There is demand response that could be used as a substitute for storage. There is energy efficiency that could be used to some extent. So there are lots of different things that could address the same issue. Some of them, incidentally, and this is one of the key questions I want to raise to the panel, some of those technologies are large-scale, centralized, new transmission lines, bulk pump storage examples. Some of them are incredibly decentralized and distributed behind the meter, a little battery in somebody's basement. So one of the key questions is which of these technologies might win, and is the end state going to be one that has mostly distributed resources or mostly centralized resources? 1. 2, and related, all these technologies are moving forward and are improving over time. I'm curious to what extent the fact that some of these technologies have a head start, or that some of these technologies have applications outside of the power sector, may impact which of these technologies are ultimately the winners. So on the advance, I think of lithium-ion batteries, which, I have my iPhone here, and here's my iPad. Obviously, lithium-ion batteries exist almost everywhere, and they are relatively cheap now compared to some of the other bulk storage technologies. How important is that cost advantage? Or a second example, the fact that Toyota's coming out with a hydrogen fuel cell vehicle this year in sort of a production mode suggests that there's progress on this kind of storage in the transportation sector. And since the transportation sector moves much faster than the power sector, could there be a lot of progress made that comes from the transportation side as opposed to for applications that have a pure power sector purpose? That's 2. So how does the innovation dynamics determine who might actually ultimately be the small set of storage solutions that win? 3, a crucial question related to both of the above is, what do we need storage for? What's the primary purpose of why we think storage is the missing piece? So the two obvious areas are, one, historical, which is power systems have always had some amount of short-term variation. And until now, we've been dealing with the variation primarily through supply options, running peakers, running combustion turbines, you know, and ramping up, slowly ramping up and down power plants. To the extent storage costs come down, before we even talk about greenhouse gases and renewables, all of a sudden they could be substitutes for this traditional way of balancing out the system. But then renewables do come in, obviously, and climate change concerns do come in. And the more renewables, and particularly wind and solar, we have, the more there is this perception that intermittency becomes a problem, variations, short-term variations in the system. So a lot of storage applications aim at dealing with that by providing ancillary services in electricity markets, etc. The more renewables we have, and you know, we will likely have more and more renewables, the cost of renewables are in many parts of the world now cost competitive with a lot of the fossil and traditional generation. The more renewables we have, the more we also get longer term storage issues. Wind blows a lot harder in parts of the world in the wintertime than in the summertime. You know, obviously the sun shines a lot more during the day than at night and those kinds of things. So we might have different storage purposes other than just managing the short-term variations of the grid. How do the different technologies map to these applications? Are some technologies more likely to win because they can cover more, or will there be a specialization? You know, flywheels for short-term spinning reserves or frequency regulations, and I don't know, hydrogen for seasonal cycles. And then the final piece of the puzzle is all of this for companies that want to deploy storage has to happen in a market and regulatory environment. Which has a huge impact on the economics of any kind of storage device. You know, what are the conditions for selling excess power that was stored somewhere back to the grid? How are ancillary service markets designed, and how do they reward really fast response relative to somewhat fast response? What is the role of government incentives? Is the fact that there are no government incentives for storage today a bad thing or a good thing? Do just general rates, the way rates are designed for electricity, favor certain kinds of storage technologies? So those are the four themes: market and regulatory roles. What are the applications for storage that will ultimately become very dominant? How does the innovation dynamics favor some technologies or not? And how do we think about centralized versus decentralized, and all these, you know, batteries versus thermal, etc. Big themes. We're going to get to the answers right away. So what I'm going to ask now, I'm going to hand it over to our 5 panelists, who will give a very brief introduction, basically their name, their position in their company, what their company does, 30 seconds to a minute. And then provide some first comments on these themes. Which of these themes do they think are the most salient, the most important ones? Or are there others that I didn't mention? So I'm going to start with Thomas Altmann, and then we're going to move over from there. Thomas, why don't you start? I think it's on once you blow. Hello? Or shortly thereafter.
Okay, my name is Thomas Altmann. I'm the Chief Technology Officer from ACWA Power. ACWA Power is a developer, owner and operator of power and desalination plants, particularly in the MENA region. We cover North Africa, Middle East, South Africa, Turkey, Jordan, and we just expanded to Asia. We are basically fuel agnostic and technology neutral. So as a developer, we look to find the most optimized solution to generate the lowest LCOE for any project we're doing. So we're not pushing for any particular direction in a technology. For us, it's important to find the best solution for a project. That's basically what we do. Thank you.
My name is Eike Weber, and I'm the director of the Fraunhofer Institute for Solar Energy Systems, We have in Freiburg in Germany about 1,300 people working on technology solutions in the renewable energy area. We are as well technology agnostic, so that means we want to develop the most effective, least cost technologies. We don't only have the world record in solar cell performance, 46% for multi-junction, multi-layer solar cells under concentration. We have as well the world record for inverter efficiency, 99.03%. So we like to offer our services to anybody. We do believe very strongly, what you alluded to at the beginning, that in order to make the transformation to the new world of a renewables-based energy system possible, storage is a very important, a key element. And as a matter of fact, let's be honest, this element was undervalued in the last 10, 15 years. You know, we all were very busy developing cost-effective renewable energies. We brought the cost of PV down to the fantastic 5.9 cents per kilowatt hour, which is your latest project. But we have neglected that in order to use it in areas where you are not perfectly grid connected, you need storage in order to have power in the night and in winter times and so forth. And I think in storage we have now the most active technology development. We need as well to come down in the cost curve, and we need everything. We need batteries, we need chemical storage, let's say converting excess electricity to hydrogen, thermal storage, because when we have excess electricity, we can bring it into thermal energy, or we can use solar thermal, concentrated solar thermal power plants to have the electricity available at night. So I think in the next years, we will see lots of developments in this direction, and we have a very exciting time in front of us. In terms of what needs to be done, I think the first thing is cost has to come down enormously. You know, today in Germany, I can quote a cost for 1 kilowatt hour of battery storage for a PV system between 1,000 and 3,000 euros. In the same time, I can go to California and to China and buy lithium-ion storage battery packs for $200 or even $150 per kilowatt hour. So there is a huge gap, and the gap makes all the difference whether it's cost effective or not. We need to have the right regulatory environment, and maybe we will touch on this. And this is another very important issue, the financing requirements. Many projects in the whole world are stuck because the necessary financing is not there. So these are three things maybe we touch upon later in the discussion.
My name is Maxine Gavi, and I am the program director for microgrids at ABB. And actually, this is a fairly new role. Up until a couple of weeks ago, I was the global head of our solar initiative. At ABB, we're basically the global leader in power and automation, and we also have made a pretty strong stake in the ground over the last few years in renewables, historically wind, but also solar in the last couple of years. We consider storage a key component of the overall solution, regardless of generation, and the products and solutions that we provide are around bulk grid-level storage, distributed grid storage, also combining an inverter and storage for self-consumption, but also applications around microgrids. And our view as a whole on storage is that we really see a shift in the overall energy value chain. And as the grid becomes more complex because of distributed generation, because of renewables, and also the addition of microgrids, whether they're connected to the grid or completely isolated, they're going to drive the need for storage to address some of the challenges that are going to come. So we believe it's a key component. What we do not do, we're not actually a battery manufacturer. This is not a core area of competency for ABB, but we do build solutions around it, and we have products such as converters that are key components for the solutions.
Hello, my name is Christian Thiel. I'm CEO of Nest. Nest is a yet small company. We have a new approach towards thermal energy storage. We're just in the midst of constructing our demonstrating project here with Master Institute. And our approach towards energy storage is based on three principles. First of all, it's scalable. So our storage works like a Lego system. You have certain modules, and depending on requirements, you can scale up the storage capacity. Number two, it's very flexible. So you could basically store energy, thermal energy, for a day and use it at night, but you could also store it for weeks and use it, in the weeks thereafter. And lastly, it's built on global commodities. Many storage concepts use rare earth materials or others. We use basically rock and steel. However, this rock is a bit over-exaggerated, so it's sort of a Coca-Cola recipe, but it's a global commodity, so it brings down pricing tremendously. Why am I saying this? I think 2 decades ago, when the renewable energy sources like photovoltaic, wind, etc., started their journey, it was a key task to bring down cost of these renewable sources. Now I think renewable energy sources have become a true commodity, and we see an ever-increasing rise of those. I think currently we're talking about 40 to 50 gigawatts installations per annum in photovoltaic and wind. And what happens is you have renewable sources on the one hand, but since we can't switch on and off the light or the sun and wind when we need it, it creates a reliability problem. So yes, we have renewables, but it poses stress when energy supply is meeting energy demand, and the missing link is clearly storage. And I think we can play a key role in that and really revolutionize at least thermal energy storage. Along this journey, and this is the last point I would like to make, is that we discover in discussions with customers also that, in our case, a certain concept must not just be limited to storage of thermal energy. We're currently discussing about applications, for instance, of cold storage, where you can store heat. You could also store cold. And this is very important for instance, cooling chain in countries like India, where you have decentral challenges in storing food, for instance. Or we could talk about isolated industrial applications. Or if you look at fossil fuels, we could also, with our technology, for instance, balance out the optimum load of a coal power-fired plant, which then again becomes very important in their interaction with renewable sources, right?
Thank you, Christian. I'm covering the electricity energy storage side. My name is Wolfram Krause, and I work for Unicos, a system integrator for grid-scale storage systems with offices in Texas, in US, and in Berlin, in Germany. And our key expertise is that we really understand the battery cells, and that means we know what a battery can do, and we also know what a battery what a battery makes happy, and what a battery makes unhappy. Because if you're nice to the battery, it lives longer. And if the battery lives longer, it has a positive impact on your case. So our expertise is to understand the blueprint of the battery plant that really matches the application, and we have the control softwares to optimize the performance and the lifetime of the system. Why do we think that battery storage is a missing link and spend a reasonable time of our life on that topic? Because it has its purpose exactly in the short term flexibility of the system, and we're proud that last year we commissioned a 5 megawatt system in Germany that has a commercial business case providing primary frequency regulation in the German grid, and in a way we use the fossil regulatory framework for a commercial case of this new technology. That's a great case. In general, batteries can do much more. They can provide short-term power, for example on island systems or remote systems. But here the problem is, and I'm looking forward to the discussion, that on one side are the benefits. There are technical benefits. You can also realize economic benefits. But due to the regulatory framework, often it's not the investor in the system who monetizes the benefits. And this is one of the big barriers we are fighting. Thank you.
Great. No, this was a fantastic first round. By the way, I just point out, I think you can submit questions through various fancy electronic devices you may have. And if you know how to do that, you should feel free to do it. Otherwise, we'll also have mics at the end to have you ask questions in sort of the snail mail version of things. Wolfram, the last point you made, I think, is a good segue into the first question I wanted to ask, and you should all feel free to respond, although I suspect that Thomas will have a slightly different angle than I will. And that has to do with it now, by and large, in most places, the longer term storage, because you have long cycles of wind generation, is not very important yet. And the emphasis is on the much shorter time horizon services that storage provides. Now, the question is, do you each think that the technologies are ripe enough to merit wide-scale deployment, recognizing that for those same services, other technologies are competing as well? I mean, I mentioned at the beginning, in the US, climate change doesn't emerge from time to time as an important issue, but by and large, gas is cheap and combustion turbines are easy, and a lot of them are around. They can deal with a lot of short-term intermittency relatively well. There's a big emergence of demand response that, with the proliferation of things like smart thermostats, very soon smart devices at home could presumably also, they all have lithium-ion batteries in them, a lot of them, so they can basically provide balancing in a very easy and perhaps cheap way. So I'm trying to understand whether you think at present there's a real economic case. If you got the regulatory framework right, whatever right is, we can discuss that next. But if you got that right, is storage at a point where it actually can compete on costs and therefore you should expect it to be deployed on a relatively broad scale? The reason why I said that Thomas might have a different perspective is hopefully obvious to Thomas, and he'll respond accordingly. But feel free to sort of jump in.
Yeah, I do think actually that already right now we have many interesting cases where it's financially interesting to do storage. Let's start with good old hydro storage. Hydro storage is around since 30, 40 years and can serve as short-term balancing as well as long-term. And in hydro storage, it is completely neglected that any dam, any barrier is effectively storing, because when you don't need electricity, you keep the water, and if you need electricity, you release the water. I would like to cite another example from Germany. In Germany, we had very long time a feed-in tariff, which helped, of course, worldwide to bring down the cost of PV electricity. But today, the feed-in tariff in Germany, the feed-in rate offered is so small that the only economic case for own PV systems is the self-consumption, because we have a very high rate of electricity from the outlet in the rooms, and therefore the more you use yourself, your own produced PV electricity, which costs about 10 cents per kilowatt hour, the more you save. And normally in a single family household, you only use about 30% of your power yourself, but with a very simple battery system of 2-3 kilowatt hours of storage, you can bring this to 80%. And there, the key issue is the cost of the batteries. And today's costs, which I have mentioned, are prohibitive, makes no sense, but if they would come down to the costs which we have already in certain markets, then it makes business sense. So I think really the business is entering step by step. And of course you are right with these other technologies like the gas turbines, but in Germany the gas turbines have an enormous economic problem because they are used only a few hours per day and much too little hours per year to make investment in new gas turbine power plants useful. Of course, we do have these plans, and therefore we just need to maintain them. It's a different story. But to make the case for new gas-fired power plants is very difficult because of the low load factor. And I think the next 10 years will be extremely interesting. We will see on many technology areas, including hydrogen technology, which we can use as well for transportation, very exciting developments. I think it's a very exciting market with lots of economic opportunities.
I would like to jump in. The question was, I guess, if I'm not mistaken, on the business case. So thanks for that perspective. I fully agree, but I think we don't have to jump that far. We're here in Abu Dhabi, and let's just stay, along the sunny belt across Earth. There is a lot of CSP plants installed that don't, for instance, have storage yet. And I think, you know, with a competitive storage system, you can capture excess heat and turn it into revenues, because you just, you know, feed the turbine, for instance, over nighttime period when there is no sun, etc., and give it to the grid. So I think once you have a technology that doesn't cost the world and is affordable and provides a business case for any CSP plant owner, for instance, I mean, here we go. Then we can start immediately and take the, ask ourselves the big questions, but start from bottom up as well and just prove the case for storage. I think we can do that right after this session.
I guess my comment would be we shouldn't be making a blanket statement. It depends on the levelized cost of electricity, where you are when you're competing. If you're on an island, cost of storage may be competitive today because of what you're paying and what your levelized cost of electricity is. And I think from the perspective of a company that's really technology agnostic, we'll take whichever technology that works based on the application, and we think it's the one that's most cost effective. But it's very difficult to make a general statement that you know, on all applications, on all sizes, and all parts of the world. And I think it really needs to be looked at for specific applications and regions, and also depending on what the objective is and what the challenge is. If you look at Japan right now, that they're starting to look at actually implementing storage to enable more integration of renewables into the grid, versus if you're looking at a remote mine, for example, that is paying quite a bit for fossil fuel, and cost of storage may actually be economically viable for them.
Maxine, thank you for bringing up the case of the islands, because it's one of the areas where we work in, and I analyzed in quite some detail some islands in the Mediterranean. And there, the diesel price, and diesel is used there for electricity generation exclusively today. The price of 1 liter diesel is about 165 US cents per liter. And this is more or less independent on the oil price, the crude oil price, because it is not the crude oil price, but it's a transportation until the oil really reaches that island and is then brought up by a truck from the port to the power plant. So here on these islands, renewable energies are not really an option today, because the diesel power plant is a pacemaker of the electricity system. It's running 50 hertz a second and powering the system. And if you bring in renewable energies, they squeeze out the diesel, but you need the diesel for stability. And so, in this case, the storage system is a key enabler that helps to jump from a renewable share that's today limited to roughly 10% to something like 50% and be cheaper on the current costs than diesel. And if you look at the levelized cost over 20 years, you're far cheaper. But what is still important, we are cheaper today than the status quo by replacing diesel, or mostly the transportation costs of diesel, with wind, solar, and a battery system that takes over the pacemaking of the system. And this is a pervasive system working today.
Yes, Thomas, it might be good for you to take up on that, right?
Yeah, well, we look on the view of a developer, and for us the most important thing which counts is, of course, the tariff. If you use storage or not depends primarily on the tariff structure. We have cases of CSP plants where we have to, in North Africa, where we have to dispatch something like 35% of the total energy of a day within 3 to 4 hours. This is only possible with a storage system. That's why we use it. What we also can see is it will help the deployment of renewables, because we just get more generation hours per day and per year. We can extend the operation hours of a CSP plant, or in this case a CSP plant, from 8 to 10 probably to up to 24 even. We have in South Africa a CSP plant with 9.5 hours storage, and there are plants in this world, they have 17 hours storage. So it's not a limiting factor anymore. We can increase the capacity factor, we can increase the utilization of the CSP plant, which will drastically reduce the tariff. And with the storage system, you can also respond to peak hours. So this is where we see the implementation of storage as adding value.
Yeah. Before I get back to you, I wanted to sort of, in our discussion to prepare, so I want to point to you and also, I mean, Christian in some sense. So we often think of storage as being an additional cost in some ways, right? So we have a PV system, sun doesn't shine at night. I need to have buy a battery to sort of make it work a little better, right? So there are probably some technologies where that thinking actually doesn't work, where you can lower the levelized cost of the energy system that you create with storage relative to the system without. And I guess, you know, comment on that. Maybe Christian, you want to comment on that?
We often get the question, especially also this week, why our tariff for the CSP plant in Morocco is different from South Africa, for example. Well, first of all, the solar irradiation in South Africa is 10 to 20% better, which is one reason. But a significant difference between these two tariffs is that we have this criteria in Morocco with this 35% dispatch in 4 hours, which we do not have in South Africa. And there's an optimum. It sounds paradox, but if you add storage, your LCOE will be reduced. And why? Simply, if you build a standard CSP plant, which is dispatching 10 hours a day, 12 hours a day maximum, your power plant is not utilized for 100%, it's utilized 50%. If you add a storage facility, which needs some extra solar field, you're adding for relatively less cost, which is solar field and storage, additional generation capacity, utilization of the steam turbine, without building another steam turbine, another power plant. So basically, with this cost addition, you can reduce your overall LCOE.
Yeah, I would like to just jump into this discussion with the following statement. I think we should be very clear of the following fact. It makes no sense at all to build any more CSP plants without storage, because the cost per kilowatt hour of electricity from a CSP plant is almost double the cost of a PV system. However, of course, we need 24-hour electricity, and therefore my suggestion, which has not yet been realized on a large scale, is the lowest cost plant will be a CSP PV or CSP concentrated PV combination, because really one should not use much of the power of the CSP plant during the day. One should use the PV system to supply the electricity during the day. Probably the turbines have to keep spinning at a certain rate, so they should not be shut down, but collect the heat for providing the electricity at the night. And model calculations show that you can end up between 12 and 15 cents per kilowatt hour around the clock for such a combined power plant. And I would be looking forward to get some designs in this respect, particularly combining CSP with CPV, with concentrated PV, is attractive because both technologies need the same two-axis tracking. You know, the heliostats, the mirrors have to follow the sun, the concentrated PV systems have to follow the sun, so that will be something very important and cost-effective for the future.
Yeah, this is exactly what we're looking at, the hybridization of PV and CSP. However, we have to respond to tenders. We are not writing our RFPs, we're not writing the tenders. If the tenders open and say, give me so much generation per year, here's the land, here's the sun, we are free, we can do all this optimization. Typically, there is a tender for a CSP plant or for a PV plant, or I haven't seen one for a hybrid. If we look at the CSP tender, what we did already in one of our bids, we indeed use PV for the parasitic loads. Because this, of course, exactly what you explained. A CSP plant tower system has heliostats, we have drives, they use electricity, and we are reducing the cost of this electricity, what we're using inside the plant, by using PV. So if the tender is open, it's a different game. I want to add one more thought here. We should also think about how we use the electricity. It doesn't make a lot of sense to generate first the electricity with renewables and then you use it in a process in which you could use the steam from the CSP plant straight. One famous example in this particular region is the solar desalination. There's no need to first generate electricity and then you feed the electricity into a reverse osmosis plant. You're losing a lot of efficiencies. You have a lot of steps where you convert one energy to another one, from thermal to electrical, from electrical to mechanical, and so on. So just as a Ford model, you can use a solar thermal concentrated solar power plant to produce the steam and goes straight into a process which uses steam to desalinate water. And the interesting aspect of this one is here, two things. Number one, you don't need high-tech equipment on the solar side because you need a lower steam pressure, a lower steam temperature, the materials is low grade. And the second thing is, you're also using the advantage of water storage. Water storage is much cheaper than thermal storage or electricity storage, and you can combine, that's what developers do, to try to optimize different systems without being dependent on one particular type of technology. To combine electrical or thermal storage, water storage, try to take out the inefficiencies of a system, will bring down costs of electricity or the final product, which could be water.
Okay. Christian, did you want to comment or in addition?
No, I think I agree to that.
Okay.
But one remark I would like to make anyhow, a very short one, is I agree to this. So I think when considering new plants, especially CSP plants, I mean, let's go for the storage. The statement was clear. I fully subscribe. On the other hand, one thing just, and making the link to my battery colleague, is when you look at countries, for instance, with a very high renewable penetration already, Denmark, Germany, I think the next step is really not to look out for what is the competing winning system, but you know, in terms of single technologies, but how could a technology environment look like to cater to different needs? For instance, capturing the large amount of energy created by offshore wind farms during the night when there is no industry running, capture that and then apply it in the next morning to households, to industry, etc. Do it with batteries in the short run, do it with thermal energy storage for the long run, etc. So I think that is the next exciting step we have to take intellectually for those countries that really need a more concept approach than a single technology.
That's an interesting observation. I'm going to change the question I'm going to ask based on that. I mean, it's one of the themes I mentioned earlier is sort of this distributed versus concentrated. And what you just said, in the electricity industry in particular, people think a lot about optimization. They think this is a complex system. We need, you know, here are the things we need to do to optimize this, to get the least cost electric system to meet our demands. It's great. And in that system, I don't know, you know, a CSP with storage, a large CSP with storage may win, may make sense. Generating just the right mix of PV, CSP, offshore wind, onshore wind could minimize the costs. But, so here comes the but, right? So increasingly, the system is not determined by system planners. Increasingly, the system is determined by individual consumers making choices, right? Yeah, I think so. Well, I mean, you can disagree, but I mean, I don't have to ask a utility when I buy a refrigerator how big that refrigerator is, right? Generally, in most places, I don't have to ask anybody if I want to put a PV system in my roof, whether or not from a system perspective that makes sense. I guess that plus the existing retail rate structures. I'm trying to get your sense of to what extent the fact that we have more and more consumer decisions embedded in certain retail rate structures that may end up, you know, providing advantages for a lot of distributed solutions when in some sense, you know, at least some amount of sort of large-scale concentrated bulk storage solutions may make sense. So how do you perceive that risk? And are there other, so this is one of the questions that was raised, so what is the right set of government policies? What can regulators or policymakers do in that context to sort of perhaps nudge the storage evolution in the direction where the most cost-effective solution emerges? I'll start with
Yeah, I would like to start because I disagree a bit, because in many cases it's not the consumer who really decides, but it's a regulator or the rate structure a Public Utility Commission is approving. Because in Germany, for example, and we had the discussion earlier in the preparation, if you produce on your rooftop solar energy with a photovoltaic plant, you have to pay a tax on that. So there is an incentive or de-incentive mechanism to do certain things. So it's not only the individual decision, but it's mostly driven by the regulatory framework around. And unfortunately, and there I agree with you, this framework is not created by system planner who really tries to find the right balance of all components, but it's mostly driven by politics, but by lobbyists, by certain groups, so it's very difficult. This system is not optimizing on the technical point of view. And regarding the question central versus decentral storage is something I'm discussing a lot with my colleagues, and we're discussing the pros and cons on both sides. We're focusing on large-scale storage, and we see the economy of scales, and also like operation and maintenance. If you have distributed 1 million small systems and you need to service them once a year, you need 1 million house visits. It's much easier to have a big site where you do a service within a week. So there's an economy of scale for the large-scale storage systems. And the whole operation, construction, operation, you have a good scaling there. But on the other side, we discussed slightly the different business cases. Residential storage, behind-the-meter storage unlocks an additional potential of revenue streams, like in California, in US, the demand charge reduction. People pay very high fees for the demand they take from the grid, and a local battery can reduce this. So a decentralized battery has the potential to tap into this revenue stream, and at the same time could be aggregated to a virtual large battery that acts, for example, to balance the system. So this is the advantage of the small storage, this behind-the-meter storage systems, and I think there's no black and white. We need the right appropriate mix of these technologies. They all have advantages, disadvantages. The same is, it's not wind or solar or geothermal. It's a mix of all of them.
Yeah, I'd have to agree with you. Again, there is no black and white here. We need the distributed storage. We also need the central storage. And then very shortly, as already is happening in many countries, the EV charging and how you can utilize the storage from electrical vehicles in this space. The whole idea is, I think, you need all of it. The question is, how do you manage all of it? And it goes back to the utilities, which we're already seeing, especially in Germany, they're starting to change their business model to incorporate a lot of these different elements, and are they participating in part of the market that they had never done before, which is really trying not to lose touch with their consumers, but be able to bring more services to them. So there isn't one technology or one particular application, centralized versus decentralized. I think it's going to be like solar. You need both. It depends on where you are, what you're doing with it, what the drivers are. And I do believe, actually, I have to agree with you, I think consumers will make decisions on what to use, not because they care about the technology. There could be a black box. It's just, what does it mean? Is it going to save money for me? Will I be able to reduce my cost of electricity? And how much do I want to be dependent on the grid? So I think there's a lot of different variables and drivers that are going to really populate, I think, the whole value chain in the area from distributed to bulk.
Great. I see the next panel here, and I see 3 minutes and 20 seconds on my little monitor here. So I have to wrap up. We could suggest making the topic of storage the whole conference next year. It'd be pretty easy to, I think, to fill at least the panel discussions. I want to sort of just go down the road in like 15 or 20 seconds, so to contextualize it to the region. So, and responding to a question. If you were a government in one of the countries here in the region, what is sort of the single most reasonable but also effective policy tool that you would suggest be used to sort of create progress on creating storage opportunities in the region? I'll start with them, go down the road.
Yeah, I have a short answer for that. Don't put a feed-in tariff, just let the developer, the IPP, optimize the system and give you the lowest LCOE. Very simple.
Yeah, and my suggestion following what we discussed before is don't be too technology specific. For instance, having the possibility of CSP combined with CPV or PV, which gives the lowest cost of electricity, and don't try to get the best overall economic solution, which is what you alluded to, because that's probably not available. You know, everybody, every investor makes a local decision and a cost-effective decision, and after all, it comes together very well, I'm sure.
Don't favor one generation type over the other, and really start with a clear ground with all of them. Let them all start competing on their own.
So we heard storage is increasingly relevant. I think everyone agrees. Plus, there's a lot of parties involved, and it's causing some confusion as well. So my advice would be, let's create a platform and give this platform decision power so that the systems actually come alive and don't get lost in discussion.
A very local comment, oil and gas is precious. And by using batteries, by providing flexibility, you can optimize the efficiency of conventional generators.
That's a good one. So that discussion has nothing to do with renewables directly, right? That's a valid point no matter how many renewables we get. Excellent. So obviously we could continue a lot. Now the monitor says 1 minute and the people over there are beginning to sweat. So I wanted to thank our panelists. I thought it was a very interesting discussion, or I should say the beginning of a very interesting discussion. I don't know how many of us will linger out there, but I will for sure if you want to sort of keep talking a little bit. Otherwise, I also want to thank you, the audience, for listening to us, and I hope it was at least somewhat interesting. Thank you very much.